Namaskar. Good afternoon, everyone. I welcome you back all for this technical session on Mineral Exploration Hackathon, technical session on innovative mineral hunt techniques. The Geological Survey of India, an attached office of the Ministry of Mines, Government of India, is organizing Mineral Exploration Hackathon on innovative mineral hunt techniques for mineral prognostication. This event focuses on using of state-of-art techniques practiced globally, including the interpretation and modeling of geophysical data, the integration of multiple data sets, and the application of emerging technologies such as AI and ML. The aim is to utilize baseline and available exploration data to identify new target areas for mineral exploration, particularly deep-seated and concealed ore bodies. We will begin this technical session with 3 presentations, followed by an interaction between participants and the panel of judges, and conclude with a brief presentation by TF and at the end, customary vote of thanks. So now may I request Devkumar Bhattacharya, Deputy Director General and Head of Remote Sensing and Aerial Survey Division, the Geological Survey of India, to present on the problem statement, deliverables, selected area for the hackathon, and the rules and regulation. It is my distinct honor and privilege to introduce Sri Devkumar Bhattacharya, Deputy Director General and Head of Division. In the nascent stage of his illustrious career, he contributed significantly at the Malanchkan Copper Complex, Hindustan Copper Limited. Upon joining the Geological Survey of India, he was involved in mineral exploration across various parts of the Rajasthan. Subsequently, at the central headquarters of GSI in the Geoinformatics Division, he played a pivotal role in the development of the GSI portal, the online core business integrated system. His exemplary leadership was further demonstrated when he took charge as Deputy Director General of Karnataka, a state endowed with rich mineral resources. Currently, he is serving with distinction as the Deputy Director General and Head of the Division of Remote Sensing and Aerial Survey of GSI in Bengaluru. So with this brief introduction, I may request Devkumar Bhattacharya sir to present the topic. So over to you.
They will be moving the slides, no? Okay. Good afternoon. It was a very good introduction for a very common and simple man. So I don't know. I actually welcome everybody in this presentation. I'm not going to tell anything which is not there in our website. The website has been published yesterday, and you can go through. And actual hackathon and all will actually continue till maybe October. So here is just an introduction. There will be 3 presentations. I will just introduce about the problem, deliverables, rules, evaluation process, and the area. And then LMS Maura, he will tell about the data, what kind of data that we are giving. And finally, Deeptangshu will speak about the website, how to register and all these things. If somebody asks me, what in limited words, how do you describe this entire hackathon and all? So I have chosen only 4 sentences. Our objective first is we have to combine geoscience data and AIML, because artificial intelligence is such a new technology which is employed in different fields, and also we are getting it introduced in earth science data, particularly exploration and all, but that is not that much popular. And if we see the industry, they are also going into that, but primarily these things are done as a research work by our professors and research institutes. So the final aim, why all this is because we need to find new exploration blocks. As you are aware that Government of India is focusing on exploration and auctioning of mineral exploration blocks. So we want very quickly more and more exploration blocks that we can auction. Time, it's a 60 days of intense collaboration. It is collaboration because it is not purely IT, it is not purely geoscience, it is a combination of these two. Normally, as a data scientist, if I talk of a data scientist, statistician, they were aware of normal general data, but geospatial data, particularly earth science data, if the analyst is not aware of the nuances of the data, it will not be possible by simply writing a code and getting something. So it requires multi-domain expertise. So whoever will be participating in the hackathon, they must have some SME, subject matter experts, along with their IT team or the programmers. So I don't actually, I hate to read out basically, but this is the kind of a presentation where I'll be actually reading out some of the things. So as I said, that problem statement is here very generalized because we are starting a journey. For example, in Australia, I have seen in Sydney Hackathon, they give a very specific problem. They give a deposit and they say you find the extension or depth extension. You do a 3D model. Here it is not like that. What has happened is over the period of time, GSI and Government of India has invested a lot in generating baseline data. So we have a lot of baseline data there. And now we have to, out of this baseline data, we have to find new areas of exploration. So it is something like a regional data to smaller area of exploration. So that way we have to have a generalized kind of a problem here. Very important thing is that we need to locate deep-seated and concealed deposits here. We have geophysical data. We have some borehole data. So we expect the participants to analyze and find depth modeling, 3D modeling, whatever data is given, and then try to interpret that model or constrain that model with other whatever data is available. I don't know how far it will go, but this is something we expect. Of course, AI/ML, because we want that. There are classical way of doing the things, but we want AI/ML. AI/ML is basically, it's a kind of a disruptive technology. I understand that some of the way of handling, say, geophysical data, like a 3D inversion modeling, etc., that can be done using some AI/ML. So maybe you don't require a standard software for that. So how to do that? Who will be doing that is of great interest to us. How it will help in analyzing our data. Then predictive maps, of course, final outcome should be a kind of guide where we'll be telling or the participants will come out with suggested areas. As I understand, this is something which we have written, but this is kind of open thing, and we have very distinguished and esteemed judges. So many of the things they will decide later on. But in a very general perspective, I understand there will be two kinds of thing as the result that you have to upload in the hackathon portal. One will be a map, a block diagram, a section, something like this, a graphical file, and there will be documentation. Documentation is very important because end result is, though it is very important, but how we have arrived in that end result has to be documented, has to be explained properly so that your work can be evaluated. So in that documentation, these are the certain sections that we expect. It will be there, like the resource. What are the resource, hardware, software, data, what are the data available? Then if you are extracting a derived data, say for example, there is magnetic data. So if you're extracting something, a feature out of that data set, that also has to be listed and its significance has to be mentioned. Then methodology, AI/ML algorithm, whatever has been generated for this problem, degree of confidence. So if say ultimately in the output layer, what are the contribution of different input layers, some kind of assessment, so that we get some confidence about the result, genetic model, etc. Whatever is there, what have been used, and all these we should be able to visualize in open source. So we don't want any locking with some specific software without which we cannot see the result. Rules, I think it's a very standard kind of a thing. Most important is we are not restricting any group, so it is a single person, it could be a group of persons, it could be a company, or maybe even consortium of companies. So we have kept it absolutely open. But only one restriction is there. Any person who is part of one group or as an individual he is applying, he cannot be part of another group. So that is one thing. And the most important thing, I think already the site is live, https hackathon.gsi.gov.in. It has been developed by BISAG. I think have some representative technical lead of that project is here in this auditorium. So thanks to them, we could very quickly launch this website. It is hosted in NIC Cloud. There is no registration fee, so anybody can enter. And also there is no restriction in data download. Whether you register or not, you can download the data. There is no issue in that. There is no bar in the technology. Any technology can be used, or whatever resources you have, you can use that. Only you have to declare what are the resources that you use, what are the software or whatever you have used, and there should not be any infringement towards IP or something, so that if there is any complaint from any quarter, GSI will not be liable for that. 60 days time that I have already told. And before expiry of the 60 days, the solution has to be uploaded in the hackathon portal. For that, people need to register. And apart from the solution, that is the document and graphics file, whatever, two important things are to be uploaded. One is a declaration form. It is something very common kind of a declaration form against that I will not be using it will be ethical, something like this. It will be professional. So that declaration form will be uploaded there. So you have to download that, sign, and then upload. And a concept document. There has to be a kind of a pitch document, you can also say, a concept document, where we'll see how much you have understood about the problem and what kind of methodology you are actually adopting. Because there will be some screening based on these two documents, that is the declaration form and concept document. Now, after screening, the successful participants, they have to present their solution along with after uploading in the portal. So again, I will come. There is a section about how do you evaluate this. So there will be a closing workshop somewhere in the month of October probably, and in that closing workshop we will declare the result. There will be open mentoring session. So whoever wants to interact with our technical team or judges will organize technical sessions online, and there will be a specific date based on requests coming from the participants. We will hold maybe 2 or 3 days of open session over web. Actually, this hackathon, the idea of hackathon was we have established NGDR, National Geoscience Data Repository. So the point is we have established that the data are there. So how people are going to use that facility? That was the question. Though whatever we are actually giving as a data package to the participants to download, everything is there in the NGDR. but only we wanted to help them out by filtering the relevant data and all into the hackathon site from where they can download it. This AI is not all code developed during the hackathon should be in the original work of the team. So you should not borrow somebody else's code. And our judges will also see that originality is there and they will judge on that also. So for any kind of, as you know that this is for wider participation, it is like propagation of ideas, learning. So we always want that whatever things that you have done, it should be made available in somewhere so that people can also use that. That is our one kind of request to the participants. And the code of conduct, etc. that is there. Evaluation, I already have told something. There will be stage one. Stage one will be after you upload all the solution and the declaration form and the concept note, there will be a short listing based on that. And then we will be evaluating the actual document and the final 2D, 3D, whatever maps or sections that you are uploading. This evaluation will be done by our panel of judges who will be after 2 lectures, they will be introduced, and you will interact with them also. You can ask for any clarification. We have actually divided how to evaluate. We have made it, tried to make it very objective. So there are 4 different sections, or so based on which actually we'll be evaluating, and we have allocated some marks. If we change this, there is always a chance that judges may feel otherwise, but whatever we do, it will be done in a very transparent manner, and it will be published as a corrigendum or something in the website. So here, fundamental geological understanding, as you ever, once I go to the area and when Maura presents the data at the area, you will understand this is a part where a lot of minerals and metals are actually reported. And there are a few deposits also. So fundamental geological understanding is very important here about the mineral system. So that will carry some marks. And then clarity of thought. For example, there is a geochemical layer, stream sediment data. How this stream sediment data I am using to arrive at a particular mineral system, or what kind of information or input it is giving to me, this will also be actually judged. Then it is very important that data cleaning, data preparation for analysis has to be done. For example, there could be for some element in geochemistry, it will be extremely skewed distribution, whether you are actually removing certain outliers, or maybe you are normalizing. For example, you may have to transform a long normal distribution to normal for using some it in a meaningful manner. Particularly, you know that trace elements are basically skewed. That is important. Statistical tools, how you are using it, that is important. And the extraction of features I have already told. Particularly for geophysical and geochemical data, you have to, use that data judiciously along with a concept, how you are actually transferring that data or feature into your analysis and using that in the analysis. Significance of extracted features will be important. Then innovative approach applied in geophysical data processing. So how you are actually doing a modeling, etc. will be judged. And how you are integrating the data, because there are so many ways, even in AIML and classical method also, there are so many ways of integrating the layers and data-driven, knowledge-driven. So actually you are not restricting anybody. So if somebody goes with the data-driven, somebody goes with the knowledge-driven, and maybe there are other ways also. in this field, lot of researches are going on, and in global literature, you'll find lot of such papers and all. So if somebody can refer all those things and incorporate that, he will definitely be considered as a better candidate. And there will be final output or documentation. We'll be giving some marks for that. So ultimately, as our aim is to find new areas of exploration, so what are the new areas that you are demarcating, which is actually not known, because the data is available. Wherever there is deposit, wherever there is occurrence, we have a lot of, around 42 probably exploration reports in this area. So we have to see how different is your prediction, and what is the rationale behind it. Maybe I am going deeper and deeper and making things very difficult for you to, comprehend. But anyway, these are the general way. Process and clarity, as I told you. And error factor, that is also very, very important when you are actually analyzing and integrating the data. There will be presentation, demonstration. It will be online, and some marks will be there also. How you are actually presenting your case becomes also very important. Certain things that we expect that will carry some weight is that I already told, normalization process, some statistical transformations. If you're adding more data layers, as I told, so that whatever is beyond NGDR, you can have some kind of a global database, etc. And then depth sections. 3D is, for us, 3D is very, very important. So sometimes what happens when you do all these things, we face this problem. Sab to theek hai sab, drilling kahan lagayenge? So this is a question faced by us and faced by everybody. So we are drilling kahan lagayenge ka, I don't know, but at least there should be some recommendation about how to go about the next phase of exploration from this baseline data. And of course, follow-up activities I told. And whatever, if you can automate some of the data cleaning or some of the things, that will also be taken into consideration. This is the area. It is in Rajasthan. It is a Rajasthan, as you are aware, whoever is there in the geology, from the geology background, they are aware that it is very geologically diverse, and there are episodic metallurgy, and there are many commodities. It's not just a single commodity or something. We have kept this a bit open. So 21 topo sheets will be there in the area. It will cover around 14,780 square kilometer. And there are some deposits, Rajpura Dareva, you are aware, then Bhukia gold, which is recently been auctioned. And then Jhamar Kotra is also there. So these are the areas in Rajpura Dareva, you can see in the north, then Jhamar Kotra is near Udaipur, there is Zawar. All are having different kind of metallurgy or mineral systems, you can also say. And then Bhukia. So if you see the geological map, I think it is there in our document, and you can also access the geological data in GSI website as well as in NGDR. So there are Proterozoic rocks, Archean rocks. So it's a sequence. Some of the deposits are mainly in Aravalli, basal part of Aravalli, and these are the important metallogenic belts. We can say normally when we approach an area, we try to find that whether it falls into some known belt or something. So we have this Ghatol Salumbar. Ghatol Salumbar is I don't know what's that. Let us not repeat the mistake. So Bhukia is there. Bhukia to Ghatol is just south of Bhukia. Just south of Bhukia. Fortunately, I worked there for few years, 2-3 years, but not in Bhukia. There is another prospect called Hinglaj Mata. It was just north of the Mahi River. And then this belt, actually Mohra will deal with it. Let me not go into that. And there is Beraj granite related mineralization. but we don't have much idea about that. Maybe WR will throw some data or information about that. Rajpura Dariba, everyone knows, and it was one of the classical Gosans which helped in discovering the Rajpura Dariba deposits. Bethrimbi is part of the same belt. There are phosphorite, Jhamarkotra, very old, everybody knows. Mine bhi has pe. Baswara manganese, something new, I am not very aware of that. And then Rekhavdev ultramafic, we all know that. And there could be some, maybe nickel, cobalt, etc. Copper also, very recently, our director Shubhabrat was actually working there in some of these areas. So he could locate some copper mineralization also associated with or nearby to that. These are the data. So we have geology, geophysics, geochemical, and remote sensing data, apart from exploration reports. So there are the different 50K map layers, geology and mineralization. There are exploration reports. That is very important. 42. Out of that, there are 20 G4 reports, 14 G3 reports, 3 G2 reports, and also some other reports. There is STM. In geophysical data, we consider geophysical data to be very, very important because till now we didn't have pan-India baseline geophysical data. So we have surface gravity, magnetic, and high resolution aeromagnetic and spectrometric. So these are the data which we feel that should tell us about the third dimension, which we cannot see. And then NGCM data is there, that is stream sediment. Also, we have soil samples also in 5 minute by 5 minute grid, one sample. That is a very low density kind of data, but still it is there. And then remote sensing data. We are using multispectral data to generate alteration maps, and 17 type of maps are there in each scene. So that will also be part of the data. Okay, thanks. So I think I will stop here, and then Maura will take up for about the data. And at the end, when there will be an interaction session, you can ask all your questions and all. Thank you very much.
Thank you, sir. We are moving forward to the next session of this technical session that will be presented by Sri LMS Maura, DDG RMS2, that is Mineral Exploration, Western Region, GSI, Jaipur. We will be presenting on geology, data, and expected outcome. It is with me immense pleasure and honor that I introduce Sri LMS Maura, Deputy Director General and Regional Mission Head, Mineral Exploration, Western Region, Geological Survey of India, Jaipur. Sri Maura is the esteemed technical head of the selected hackathon area in parts of Rajasthan, bringing a wealth of experience and expertise to this pivotal role. At the onset of his distinguished career with the GSI, Sri Maura was deeply involved in mapping and mineral exploration across various parts of Rajasthan, contributing significantly to the understanding and discovery of mineral resources in the state. His exemplary work in Rajasthan laid a strong foundation for his career and set a benchmark for excellence in mineral exploration. Sri Maura's expertise was further recognized as he took on challenging assignments in the northeastern states and central India. His extensive fieldwork and strategic insights in these diverse and geologically complex regions have instrumental in advancing mineral exploration initiatives. His dedication and contribution have not only enriched the Geological Survey of India's mission, but have also played a crucial role in sustainable development of the country's mineral resources. In his current capacity as Deputy Director General and Regional Mission Head, Sri Maura continues to lead with vision and commitment, ensuring that innovative approaches and cutting-edge technologies are employed in mineral investigations. His leadership in this hackathon is anticipated to drive significantly advancements and uncover new opportunities in the mineral-rich landscape of Rajasthan. With this brief introduction, I welcome Sri LMS Maura sir to second presentation on data, geology, and outcome. Over to you, sir.
Good afternoon. So I'm thankful for this a very generous introduction of mine, even though I don't think that I am for that. Anyway, so I am giving a very broad idea about the geology of the area and the data we are going to give to the participants for taking in this hackathon and what is the expected outcome. Some of the parts Mr. Dev Kumar Bhattacharya have already covered, and now I start. So let's start with the geology of the Rajasthan. Next, please. So this is the very generalized map of the geological geology of the Rajasthan. Geology, this Rajasthan, it occurs in the northwestern part of the India and the Indian craton in the northwestern part. And Rajasthan is richly endowed with the geological milieu as well as the minerals. In broadly, it comprises the rocks of the from the Archean basement rocks, Archean, up to the Quaternary, and except few, okay, except the Paleozoic sequence, and we have the Archeans, we have the Proterozoic rocks, we have the Mesozoic rocks, we have the Tertiary, and finally this Quaternary sediment rocks. So in इसमें pointer भी है क्या? Pointer नहीं है. So if we geologically, if we go for the Rajasthan, so in this part of the area, we have the Archean rocks here, and earlier this part was known as the banded gneissic complex. Now we describe it as the Bhilwara supergroup of rocks, and broadly we divided it into three major groups. And the one from if we go from west to east, the grade of metamorphism increases, and in the west it is the Saint Mata complex, and in the east central part it is the Mangalwar complex, and eastern part is the Hindoli group of rocks. So in these parts, Saint Mata complex, pointer. So this Saint Mata complex rocks, this portion, this is contains the granulite facies of the rocks and some inderbites, some other high grade rocks, charnokites, as well as some this high grade rocks within this Saint Mata complex of rocks. Then the medium grade of rocks of Mangalwar complex, these is mainly comprises of the migmatites, granodioritic gneisses, and some amphibolites are present. And Hindoli group of rocks are the low grade of metamorphism, mainly comprises slates, phyllites, and some volcanic sediments are present within this Hindoli group of rocks. And these basement rocks are overlain by the Aravalli supergroup of rocks and the Delhi supergroup of rocks. Within this Bhilwara supergroup of rocks, there are some small basins present within this Bhilwara supergroup rocks, which are equivalent to the Aravalli supergroup of rocks, and these small basins, age-wise, they are of the Proterozoic age. So the Aravalli supergroup of rocks are occurring in the lower part of this Rajasthan, in the southern part, and the Delhi supergroup of rocks are extending from in the north, from almost from Delhi, Haryana through Rajasthan and up to the Gujarat states. And earlier we divided them as the South Delhi fold belt and North Delhi fold belt. Some are agreed, some are not, but mainly these are the medium meso-proterozoic group of rocks. Beside this, we have the Vindhyan supergroup of rocks, which belong to the meso to upper proterozoic of group of rocks. And then in the western part of this is the Malani supergroup of rocks, which are occurring in this. And this basement rocks, they are intruded by some granitic rocks of the older age. And then further west, if we go, then there is some intrusives of the Irinpura granite and Sandra granites. And then This Mesozoic group of rocks occur in the Jaisalmer basins, and Malani igneous rocks are of the bimodal volcanic rocks, and some tertiary rocks in the Bikaner basin where we got the lignite deposits in the Rajasthan. So mineral wise also Rajasthan is also very rich in the state. And आपने मेरे को पॉइंटर दिया था ना, पॉइंटर दिया था where I kept that आगे बढ़ाने के लिए पॉइंटर दिया है उसका वो तो मैंने so if we go now, we mainly concentrate because our area is falling in the southern part of the Rajasthan when mainly Precambrian geology, Precambrian rocks of the Rajasthan are exposed. So a little bit about them. The Archean basement rocks of the Bhilwara supergroup, as I already told, this portion, this red portion, this is called the Archean basement rocks, and we divided them into the three groups, Sand Mata groups, then Mangalwar groups, and then the eastern part, it is the Hindoli group of rocks. And then these Archean rocks are included by the Untala and Gingla granites, which are older, they dated about 2.8 GA, and then the Barrage granites, which is aged about the 2500 million years. And the Proterozoic of the Aravalli and Delhi supergroups, then some, as I told, within these basement rocks, there are some basins which contain rocks of the Proterozoic age. These are the Jahajpur, Rajpur Dariba, then the Savar, Purvanera, these group of rocks occurring within this basement rocks. The Aravalli supergroup of rocks, they are confined to the southern part of the Rajasthan, and they extended from Bhilwara, Rajsamand to up to Champaner in the Gujarat. And this sequence, they mainly comprises the clastic and chemogenic sediments with the interlayering of the basic volcanics in the basal part and showing a very complex deformational history and change in the depositional environments. It mainly shows two distinct phases within this Aravalli supergroup of rocks, and one is the deep sea phases and another is the near shore shelf phases rocks in this Aravalli supergroup of rocks. And broadly, we can divide this Aravalli supergroup of rocks into three groups: the lower Devari group, which comprises polymetric conglomerates, quartzites, phyllites, basic volcanics, and the dolomites and the carbonaceous phyllites. Then the middle Udaipur group, which comprises variegated phyllites, quartzites, phosphoric stromatolitic dolomites, chert and amphibolite schist. Then the upper Jharol groups, which comprises mainly phyllite schist with some thin bands of the quartzite. So this is a geological map of the जो है हमारा उदयपुर सेक्टर में जो वहाँ का टाइप एरिया है फॉर द उदयपुर ग्रुप ऑफ रॉक्स एंड हियर यू कैन सी a clear distinction between the near shore rocks which occur in the eastern part, and in the western part is the deep sea phases which mainly comprises phyllites and the schist and some thin bands of the quartzites, whereas the eastern portion we got the dolomites, we got the phyllites, we got the quartzites, and different some basal part we got the metavolcanic rocks also in the eastern part of this. Then if we come to the Delhi supergroup of rocks, which are sandwiched between this Mangalwar supergroup of rocks, this Archean basement rocks, and in the western part, this Marwar supergroup of rocks and Malani igneous shoots, and this form the Delhi supergroup of and backbone of the main Aravalli mountain ranges. And the main rock types in Delhi supergroup of rocks are the quartzites, arkos, these are the conglomerates, there are phyllites, there are marbles, calcite, various type of rocks are present there. And some mafic flows are also present there. Some volcanic rocks are also present within the Delhi supergroup of rocks. And these are the emplaced by some granites known as the Sendra granite, Ambaji granite, Berar. In northern portion, they are Dadikera and Harsora granite. These are the various granites which are included into Delhi supergroup. So as this, we have the area, why we have selected this area for this hackathon period. Because this area comprises various known mineral deposits, as well as it has a varied geological informations. We have lot of informations about this area, or in the as a baseline data we have in this area. So we selected this area for this hackathon. And this area, as we have given the name Dariba, Bhukia, Banswara sector, different mineral systems occurring in this portion. And this area comprises nearly 21 toposits and comprises 14,780 square kilometer in this part. So these are the, here in this portion, mainly the basement rocks of the Mangalwar complex, and then the Arauli supergroup of rocks, and some proterozoic basins within the Mangalwar complex, and a little bit Delhi supergroup of rocks occur in the northwestern part. These portions occur within this. So this eastern and the central part of the area consists Bhilwara supergroup of rocks. So this is the Bhilwara supergroup of rocks, mainly the Mangalwar complex of the rocks, and it consists primarily gneissic and migmatites and the low-grade rocks with the volcanics of the Hindoli group. This one is the Hindoli group of rocks, this blue one. And then Untala and Gingla granite occupy the central part of this one. These are the Untala and Gingla granite. They occur in the central part of this. And then in the eastern part, we have the Beraj granites here, and with some shear and this silicified zones and north-south trending quartz veins are occurring within this Beraj granites. And then the south and southwestern part, in this portion, we have this Arauli supergroup of rocks, and mainly this with Udaipur group and Devari group of rocks. Jharor group of rocks are not occurring within this area. A little bit they may occur in the southwestern corner, but mostly it is comprising the Udaipur group and the Devari group of rocks in these portions. And then within this Mangalwar complex, the proterozoic basins which I told, they are the Rajpur Dariba basins, then which is expanded at Jasma Bhinder belt up to this portions, a little bit Purbanera belt, which occurring in the northeastern corner of this. So these are, then I am telling you rocks where are occurring. Then within this portion, why we have chosen, as I told, it is the important, some known, well-known mineral deposits are there. Bhukia gold copper deposit in the Baswada area here, and then the Rajpur Dariba lead zinc silver deposits in this portion. Then the Jhamar Kotra phosphorite deposits which occur somewhere here. And these are the well-known deposits, and Jawar just on the boundary of this area here. And they are different in the metallogeny, and different rock types are present there. The host rocks are different. Nature of mineralization is different in these areas. And these well-known deposits, prospect of graphite and manganese, are also known in the Banswada area and Rajsamand area. So in Banswada area, we have known prospect for the graphites and the manganese, as well as near the Nathdwara west of this. Here some manganese occurrences are reported within the Rajsamand districts. And then this copper and molybdenum are reported from the Beraj granites here. And some incidences of copper mineralization are recorded in the peripheral part of the Untala and Gingla granites. Then phosphorite occurrences beside this Jhamar Kotra, some phosphorite occurrences also reported in the Baswara district, that Salopate areas. And then some incidences of chromite, nickel and PG are reported from this Rikhabdev ultramafic rock, which are occurring in the southwestern part. So this area is important for finding out some new areas for the mineral exploration. Data for mineral exploration hackathon, we are giving the geological data, geochemical data, geophysical data, and the remote sensing data. So geological data we have given as already this is the area this we have already described. So these are the main layers we are providing. Lithological data, all these are available in the website, then shape files in the form of shape files, then structural data, lineaments, fold, fault, shear zones, all these geomorphological data, then mineralization regarding this mineral occurrences and status map of the exploration, and then exploration reports, 42 exploration reports we are providing of the different stage reconnaissance, preliminary exploration, some detailed explorations, and then STM reports, which are on the 1 to 25K, 12 STM reports are also has been provided in the websites. Similarly, geophysical data, we are providing the magnetic data, aeromagnetic data, then gravity data. This is the ground gravity data, which are collected during the National Geophysical Mapping programs. Then NGCM data, National Geochemical Mapping Program, we are providing the 21 toposheets analytical data. And in various these mission 2 reports and STM reports, these petrochemical data are available and that can be extracted from theirs. And we are providing this for the NGCM 19 reports, and some extra thematic maps are also prepared and they are uploaded in the websites. So these are the some geomorphological land layers. These are some structural elements we are giving. Then the geophysical data. In geophysical data, we have some old data which occurring in the western part and some new data. These are collected during the 1960s, 70s. These are the TOS data. This is the Operation Hard Rock data and BRGEM data. So in Operation Hard Rock, because in these they have the different line spacings is and as well as the survey altitudes. So these data have been compiled together and one single layer is formed for these data. And this TOS data, TOS2 data, they have already in 300 meter spacing and survey altitude of 80 meters. That both data, why we kept both separately for the years. So these, after compilation, we prepared one single layer for this and we are giving this with the data. So then some different derivative maps we can generate it with these data, like this first derivative maps, analytical signal maps. And these data can help us in finding out some deep-seated which are not available to the surface, some deep-seated conducive zones where mineralization may occur, some one of the objective of this. Then this gravity data we are providing, which we have collected during the National Geophysical Mapping programs. The data are collected at the 2.5 square kilometer per station data. And then these total gravity stations acquired in total area is 11,673. So these are the Booger gravity anomaly data we are providing with them. And then the geochemical data, the data of the 21 sheets are available, which are analyzed in different packages like this by the different methods. And the data which the geochemical data, these are for the stream sediment data, and these are collected toposheet wise 1 kilometer by 1 kilometer and analyzed on the 2 kilometer by 2 kilometer grid. And these data we are providing. This, for example, one map we have prepared with some data of these 21 sheets for the copper. Similarly, for the different element, the data comprises nearly this from 36 element to the 52 element data are available in these reports. And so these data can be used along with the other data for finding out some new areas for the exploration. And then remote sensing data is also providing along with these data. These are expected. These can be also expected from there. And what are the expected outcomes? The expected outcomes we have already, Dev Kumar Sahab have already described. The main purpose of conducting this hackathon is to find out with all integration of all these data and implying some new techniques as well as the classical techniques and finding out new potential areas for the gold, for base metals, for phosphorites, manganese, graphite, with some predefined areas, and with this predefined areas and using the available baseline data, and by applying any classical method and this particularly this emerging technology, this artificial intelligence we want, and some locating deep-seated concealed mineralization bodies with depth modeling, and then generation of the predictive maps showing exploration targets, visualization through maps, sections, and 3D blocks. And this Dev Kumar Sahab has already described about all what are expected in the solutions from the different participants. So I hope this, by giving this broad idea about the geology and other details, all details are already available in our websites. So it can be collected from there. So I think, thank you. And
Thank you, sir. Thank you for a detailed presentation on geology, data, and expected outcome. I hope the participants would able to understand the data which is available with us and expected outcome. With this, we are moving forward to the next technical session by the Sri Dibdanshu Sengupta, senior geologist from CHQ, GSI Kolkata, who will be presenting on registration process, data download, and uploading of solutions by participants. Unrelated, and to introduce Sri Dibdanshu Sengupta, senior geologist at Central Headquarters, Geoinformatics Division of GSI, Kolkata. Sri Sengupta is a pivotal figure in the creation of the Hackathon website, collaborating closely with the BISAC. With a specialization in structural geology, he began his career in specialized thematic mapping program of GSI in Jaipur, Rajasthan. Since 2015, he has been posted in various missions, and particularly is working in Mission 3 at the central headquarters, where he has been associated with several prestigious projects. Notable among these are the creation of the Digital Seismotectonic Atlas, the development of a unified legends for 1:50,000 scale geological maps, and the integration of the NGCM database into Bukos. Furthermore, he has been actively involved with the National Geoscience Data Repository since its inception. Sri Sengupta has also made a significant contribution to the scientific community, having authored for many national and international publications in peer-reviewed journals. With this brief introduction, I request Sri Dibdanshu Sengupta to take over the technical session. Okay.
Oh, it's all right. A very good afternoon to all the dignitaries, those who are present over here today from both within GSI and outside organizations. Myself, Dibdanshu Sengupta, and I'll be briefing about the website that we have prepared to disseminate all the information as well as the data set that is required for someone to know about this hackathon as well as to solve this problem statement. Starting from the brief overview of the hackathon, the purpose or objective of this hackathon, how to participate, who can participate, and what is expected from the participants, what they have to deliver, and how to deliver. Every information that is required for someone to know is present over there in this website that I will shortly talk about. To access this website, you have to go to this particular URL, which is https://hackathon.gsi.gov.in. You can note it down. It's https://hackathon.gsi.gsi.gov.in. Now, if you go into this particular link, you will be able to see that this web page where the hackathon poster is there. But the most important part of this web page is this top part where all the data sets and informations are given in several tabs. If we zoom that particular area, we'll be able to see there are 5 important tabs are there. I will go one at a time. But no matter in which tab you are, this right part of this website will not go away. It will stay over there because 2 most important portions are over there. First one will be used for logging in and signing up. I'll talk about it in detail later. And in the later part of this panel, we'll get to know about the important dates and the timelines that one is required to know regarding this hackathon. Now, going back to the tabs again, the first tab I have already mentioned about it. The second tab contains the brief overview of this hackathon, the overview, the purpose of this hackathon, and also the major guidelines regarding how to participate and who can participate about it. In this tab, you will be getting a general idea regarding this hackathon. And if you want to just dive deep and go deeper and want to know more about this hackathon, you have to go to the third tab, that is the document. And in the very top part of this document tab, there is a button that is called the complete hackathon document. So whatever the information that is given in this website, you don't have to, if you don't want to go and read from the website itself, you can easily just click on that particular button and just download in a PDF format for your offline reading. It is all there in that complete hackathon document. Now, this particular tab also contains two other sections. One is the problem statement. The detail about this problem statement has already been conveyed by Dev Kumar sir. And there is a button just beside that problem statement. There is a button just beside the problem statement, that is the download button. And you can just one click in that download button, and the entire detail regarding this problem statement will be downloaded as a PDF form for your offline reading. If you just scroll down into this particular tab of documents, you will be you will be getting this rules and regulations part in this same documents tab. And the detailed rules and regulations tab all can also be downloaded in PDF format by click on that document button just beside that rules and regulations. Now, these are the information that you will require to know about this hackathon, but to solve that problem statement, you also need the exact actual geoscientific data sets. So we have already kept those data sets in this data tab. All the geoscientific data set that you will need to solve this problem statement is over here. And all you have to do is to click on these URLs, and you will be able to download the geological data, geochemical data, geophysical data, exploration reports and other data, remote sensing data, whatever the data set that you will need. You will be able to download it from this data tab. And there is also an background information brochure over there. You can just download this right up by clicking on the download button beside it. Now, whatever the data set as well as the information that I have mentioned till now can be downloaded and can be accessed without registering in this website. And so it is actually encouraged, it is actually recommended to go through all this information and the data set before registering, because once you register, we will consider you, we will treat you as a willing participant. Now, if you finally want to register, I will mention the registration procedure right now. Registration procedure will be managed from this particular area in the top right corner of our website. And here, if you already have the credential, you can log in with your username and password. And for registering for the first time, you have to click on this particular tab, this particular link. And clicking on this particular link, you will be directed to this registration form over here. It's a very simple form. And in the very first thing in this registration form is the what type of participant you are. The types of participant has already been described by Dev Kumar sir, and there are 4 types of participants. It can be group of companies, individual company, or group of individuals, or any individual can join. It's a very open thing. And after you select the type of participant you are, you will be able to just enter all the names of your companies, if you are group of companies, and the name of all the participants, individual participants. But no matter how many participants are there in your team, there has to be one team leader that is called the group head here. And you have to enter the name of the group head, the email ID and mobile number of group head, and you have to suggest an username and password as well. And after you click on that sign up button, you will be signed up, and you will be ready for uploading your solution or your deliverables in this website, which brings us to the last but not the least tab, that is the dashboard. And if you click on that dashboard without logging in, you will see some message like that, that you have to log in before you access this page. And once you make your registration, you make your credential, and with your credential you log in. And after that, if you click on this dashboard, you will be able to see something like this, where you have to upload 3 documents. First one is the declaration form that Devkumar sir in your first presentation has already said that it's a very simple declaration form regarding that, just declaring that you will be ethical and no fraudulent activity will be there. So you have to download this declaration form with this download button, and you just sign it and scan it and upload it, this declaration form. After that, you have to upload a concept note as well. This should not be very large document, or maybe 10 pages with 12 font size. It is written over there. And after uploading this document, declaration form as well as the concept note, you have to upload the actual solution for the project works, and there you will be able to add more than 1 files. You can also zip more than 1 files and upload it over here. And after that, you will be able to submit your solution. So this is all in brief regarding this website, and you are being requested to go to this URL and see yourself. Thank you. Thank you, everyone.
Thank you, Dipsanshu Sengupta, regarding the registration process and downloading the data. Now we are moving forward to the next episode of this technical session. So it's a time to interact with our jury members. So I will be introducing the jury members one after another, starting with the chairman. So I'm very happy and privileged to introduce Dr. Joyce Bakshi, who is also the chairman of the jury member committee. With great pleasure to introduce Dr. Joyce Bakshi, who is the Additional Director General and Policy Support System of GSA at Central Headquarters, Kolkata. So he has notably worked in many field of geoscience, that includes stochastic modeling of lead zinc deposits at Rampura, Agucha, Rajasthan, studies on ternary sediments and sedimentology, statistical analysis and GIS studies, and the geomorphic parameters affecting runoff and siltation. Additionally, Dr. Bakshi has conducted significant research on sulfide mineralization at Malanchkand. Currently, is holding the chairman as a hackathon committee, jury member committee. So with this brief introduction, I request Dr. Joyce Bakshi sir to occupy the dais. So the next member of the jury member is Dr. Alok Porwal, who is the professor from IIT Bombay. I am privileged to introduce Professor Alok Porwal, Institute Chair Professor at the Center of Studies in Resource Engineering at IIT Bombay. Professor Porwal holds a PhD in Mathematical Geology and Mineral Exploration from Utrecht University and ITC, the Netherlands. Prior to joining IIT Bombay in 2010, he served as an associate professor at the Center for Exploration Targeting at the University of Western Australia, where he still holds an adjunct position. Professor Porwal's research encompassed exploration targeting, mineral system studies, and the application of data science, AI, and ML to geological research. Professor Porwal has been recognized for his exceptional teaching with the Professor S.P. Sukhatami Award for Excellence in Teaching from IIT Bombay. A prolific researcher, he has authored over 75 highly cited papers in peer-reviewed international and national journals, and he serves on editorial boards of 4 prestigious journals. Widely acknowledged as a global expert in mineral exploration targeting, Professor Porwal's contributions are highly esteemed within the international research community. With this brief introduction, I request Dr. Porwal sir to occupy the dais. The next jury member of our hackathon committee is Dr. Surendranath Somala. I am pleased to introduce Dr. Surendranath Somala, an associate professor at the Indian Institute of Technology, Hyderabad, where he also serves as a research coordinator. Dr. Somala's research interests and diverse include generative of AML and LLM chatbots, multimodal AI and ML computer vision, hyperspectral and ultraspectral remote sensing, induced microseismicity from shale gas extraction, multi-assort early warning systems, and gravitational wave. Before joining IIT Hyderabad, Dr. Somla held the position of senior scientist in physics at Pinnacle Halliburton, UK. His extensive publication record includes over 70 publications in national and international journals, highlighting his expertise in various fields of geoscience. His contributions have been recognized at major international conferences and workshops, underscoring his impact on both national and global scales. So with this brief introduction, I may request Somala sir to occupy the dais. The next jury member of our hackathon panel is the Arun PV, who is the assistant professor in computer science engineering group and research coordinator at the Indian Institute of Technology, Sri City, Tirupati. Before joining IIT Sri City, Dr. Arun was a research scientist and associate vice president at Huawei Technologies. He earned his PhD from IIT Bombay and completed postdoctoral research at Ben Gurion University, Israel, where he received prestigious fellowships. He has published over 70 papers in national and international journals and conferences that leads the Special Analytics and Machine Intelligence Group at IIT Sri City. Dr. Arun has been the principal investigator for the projects funded by the ISRO, DST, and the Indian Army, receiving special appreciation from the latter for his contribution to the district project. So with this brief introduction, I request Dr. Arun PV to occupy the dais. So there is another eminent person as a jury member who is joined virtually through us through WebEx link, that is Dr. Anand Singh. I'm very happy to introduce Dr. Anand Singh, who is the associate professor in the Indian Institute of Technology, IIT Bombay. With over a decade of experience in teaching and research, Dr. Singh specializes in geophysical inverse theory, focusing on the development and application of advanced algorithms, particularly AI-based joint inversion methods. Dr. Singh has published over 16 international research articles and presented 25 papers at national and international conferences. Dr. Singh is actively involved in several professional societies, including life membership with the Indian Geophysical Union, associate membership with the Society of Exploration Geophysics in the USA, and membership with the American Geophysical Union. He also contributes to the field as a guest editor for Geophysical Prospecting, each journal, and serves as the secretary for the Indian Institute of Mineral Engineers, Mumbai, Pune chapter. Welcome, Anand sir. So with this, we are moving for the next episode of this hackathon program, that is interaction between the participants who are going to participate in this program, so they can directly interact with the judges. If you have any queries, they may directly interact with them. So with this, I'm handovering the session to the Joyce Bakshi.
Thank you. I would request you would like to say something. So some brief statement, very brief statement.
Yeah, I think one of the reasons why the hackathon exists is, of course, the trend of AI MLs that are coming up. And certainly the humongous data from geological, geophysical, and whatever you've seen on this previous presentation that I don't want to repeat. The AML has basically formed, computer vision has formed like the eyes of the computers, but now the LLM chatbots have made it a lot more easier for everybody to mix and match multimodal data sets, be it PDFs, images, text, and everything. And you can come up with data insights into as to where to drill. Yeah, one thing, of course, is you need to identify various minerals based on the given data sets that are already there, which form PDFs. But what's more important, a question to the GSI itself, or the organizers, is will they take back the prize money if at all they end up drilling there and not actually finding what is already predicted? With that, yeah, thank you.
It's a brief statement.
Yeah, so, well, it's very interesting because combination of geology and algorithms. So I wouldn't say machine learning, but any standard statistical techniques or machine learning or AI, but you would need geology as well. So the best thing would be to have a team where you have a geologist, a subject expert, and a coder, and that's how it works. For those of you who are interested, this hackathon model, probably if you want to learn more about it or understand how it goes, there are a couple of PhD theses. One is my PhD student, Malcolm, he finished last year. It's exactly the same thing, multiple data sets, deriving different layers, combining them, and generating exploration blocks. And the other is 25 years old. That is my PhD. So, and the study area is exactly the same that's being shown here. So there's the same area where I did my PhD, but using much, much primitive data sets. Now the data sets are much better. So thank you.
Thank you. And already you heard from the eminent members of the jury. So just to add, this hackathon, I think the specific, the significance of the hackathon is that it bridges the gap between the two domains. It's a geology and, the ML or the algorithm domain. So, I think from the interactions that we had among the panel of judges, we aim to see, we are expecting reliable, reproducible, and generalizable approaches, and moreover transparent approaches. So I think already the presentations have made it very clear. So thank you for the opportunity, and thanks.
So Singh, Professor Singh, is there online? Will you be? Professor Anand Singh, will you, will you like to say something? A brief statement.
Yeah, so very happy to see the way it is going, and I would like to add few points that the data set is very, very nice, and I was just looking for the data set, and which is very challenging at the same time also. So those who are participating, I request them to put uh, a team of geologists, geophysicists, and if you have a computer science background for programming, and apart from that, you need a remote sensing person. So try to choose a combination of teams. It will be very, very difficult for individual participants to win this hackathon. So just a suggestion on how teams should be.
Thank you. So just to summarize, I think much have been said. I'm very happy to see so many participants. I don't know how many will really participate in this hackathon, but just to summarize, lots and lots of data is there. Now the issue is how to extract the information out of it, extract the structure out of it, so that we get some reliable outcome. If I were you, because you will be judged, your submissions will be judged by a group of members, the juries. So they should be able to judge you. If I were you, I would keep part of the area as a set which will be used for testing your model or your hypothesis. And then how robust is your model? How robust is your understanding of the area, understanding the structure of the data sets? That can be tested in the area which has not been used for developing your models. So that would be better for us to evaluate, for me to evaluate, and others, they will also use their own methods. How clear is your logic? How coherent is your reasoning? And this also will be used for checking out. In geochemical data, there is the plain statistical, multivariate statistics are used, which is sufficient to extract the structure. But to integrate all of them, you possibly require a lot of more statistics, more of stochastic or more of AI and ML for getting a reproducible outcome. Geophysics, I have issues because there is issues because non-unique solutions are there in geophysics. You can have multiple solutions of the same data sets. So how you use it, what is your reasoning, and how you're able to correlate with the already existing data set. You have seen the 42 reports of their exploration reports, not truly a blank baseline data. It is a pre-competitive data is also there, quite a bit of it. And there's already existing mines. So you have an area which is very potential. You have lots and lots of baseline data, lots and lots of pre-competitive data, and all kinds of data, geophysical data, both aerogeophysical and much more coarser ground geophysical data. Now it's up to you to extract the data and present it well, coherently, and in a way which gives rise to an outcome. I would like to rather see an outcome. Which at least may be testable in some degree. So that's all I would like to say. And if anything you would look to ask us, you're free to ask. How many, by the way, are okay? Good. Thank you very much. The first hand is up. Yeah.
Thank you. Good afternoon, judges, and thanks for all your comments and looking at complete day's deliberations. Quite things are clear. My name is Dr. Pranay Sanghvi. I'm representing a company called Summit, who has a tie-up with Australian company called Intrepid Geophysics. And we are going to one of the, let's say, hackathon competitors here. Said that I have few questions, if you permit me to ask regarding the event. Okay. So the first one is, can we have on your website a summarized document summarizing the challenges of the area, plus what is the work so far done in the area? You have 42 reports and so many things, what I have been hearing, but a consolidated work, what has been
No,
done.
that's what we're expecting from the participants to
No, sir,
integrate. and find out-
my question is very simple, because at this age, when I went talk to the youngsters or somebody, they say that why do you have to create 2 + 2 = 4 machine when it is already available? So I need to do work which is not done or which could be done better. So I need to know what are the work done in the area that will be beneficial for other competitors, but your call, please. That is what my suggestion is.
All data, reports, everything is available.
I am, sir, requesting only for a summarized statement.
Summarization of a 42 reports exploration and 21.
No, summarized statement of challenges, one, and second is the work done. It's not that entirely you have to elaborate. 10 things you have done.
To be very frank,
Just to go through the data. Then you will find how much data.
I know, sir.
यदि आप देखने से आपको ऐसा लग रहा है, just go through the data, then we'll imagine how.
4,000 samples with 62 variables of NGCM data. Just you can imagine the matrix.
Sir,
4,000
I understand the magnitude of the data. And
Huge
for registering, I definitely cannot go through that before your scheduled date. So I was just looking at a summarized statement, but it's up to you. And that's my suggestion. Okay. The second point was, okay. The second point was, you have data list does not say whether it is a merged geophysical data or all over the area, or they are the separate grids. That's number one. If any challenges are observed in that grid data, will the raw data made available to the contestants? And third, I also do not see the radiometric data set into your list.
Radiometric data is there. TUAS 2 did not have radiometric data, right? And NAGMP was not covered over this area. So I think radiometric is not there, no?
Yeah.
From here?
Rajaram, you can elaborate,
Raj-
but it is mass data.
No, first tell me whether radiometric data is there or not. No, it's not there. So one answer is straight no.
Right.
And second, it is merged. Talk about the data sets.
Sir, the data, basically it's a grid data, so it's a merged data. You will have two sets of grid data. One is of a higher resolution, which is on the eastern part.
Right.
And another block, that is on the western part, is the merged database with a combination of different sets of data, which was collected at different points of time.
No, that I have seen on the map. My question was whether all the data of higher resolution and the previous vintages data are gridded together and as available as a combined grid, or we are still in a separate?
No, because basically these are two different grid sets, so we don't want to combine because the higher resolution gets diluted if we combine it.
Okay. And as I said, you had already cleared about the radiometric data set, so that's fine. Thank you. But if any issues are seen in the grid data, will the raw data be made available?
Raw data geophysics is a problem, no? It's a problem. We will not be able to give.
So we'll go ahead with that limitation of grid data.
Yeah.
Right.
Yeah.
Thank you.
No, rounded off. Rounded off data.
Whichever is available, let's say airborne data you have, and if airborne gridded data has some issues, if issues are there.
There are
if
some
nothing,
issues
we
are
will-
there.
Yeah.
Whatever is available, you be in touch with our members. We will be able to give whatever is givable.
Right. Yeah. Okay. So hackathon is a sir competition. So I know that we'll be rewarded or whatever if successful. But since this work is going to provide a way forward to GSI and a lot of inputs will be given out of this work, my question is how GSI will engage the winner of this hackathon?
Well, that's a very good question. We have also raised this up with right forum. There is one possibility of engaging this agency, which we feel has a huge potential of using this data and getting an outcome. So there is a scheme of SNT or Ministry of Mines where we do support startups and this kind of agencies for exploration purposes. So what we have talked with the Ministry of Mines is that this is possible. Once this we decide, we on the jury decides that it's a very good solution. So their proposal can be routed through this SNT program, Ministry of Mines, and supported for the exploration.
Oh, means it will carry some weightage of hackathon
Yes,
award?
yes.
Okay. And another thing is, since all judges have seen the data and everything, the timelines, do you think 60 days are good enough?
It's a challenge, but this is a challenge for the hackathon. Hackathon is a challenge.
So is there any scope, because
No, as of
everything
now,
is
no.
spoken by data, not by me or not by you. So my question was 60 days, is it a stringent limit?
Can I add to that? The thing is that data processing analysis is going to take about 2 to 3 weeks. I do this work on daily basis practically. So 2 months, yes, it's an ample time for generating a prospectivity map for that study area that we have. So it shouldn't be a problem.
Okay,
And-
my worry was,
and-
since we have a vintage data and variety of data, I
Yeah,
think
but
60 days could-
a team has to work on that. So if you can work individually, meet the challenge, good enough. Otherwise, fix a team and it works.
And the day 0 starts from 2nd of August, right? The last date of registration.
Yeah. Thank you very much.
If we register now, so possibly you get 15 days extra.
Thank you very much.
Good afternoon, sir. Myself, Dr. Satyanarayana, from representing critical mineral trackers.
Yes, we have met you.
In fact, you have shown the 21 topo sheets. 21 topo sheets. If you see the diversified geology is there, and I don't think people who practice AI, it is very difficult to come with a model to represent the entire area. So my question is, whether you are giving a specific area, then it will be better than giving the big size of 14,000 kilometers something. I think it is difficult for anyone. People, I think.
No, we have decided 14,000, we stick to that.
No, you cannot represent a model by 41 model.
I know it's a bit difficult. So what you can do is sector-wise,
No,
that is your solution.
What-
Sector-wise models or something.
There is always trade-off between prediction and accuracy. So we have to compromise one of the things when we go with a single model for representing entire area. So that's what I'm putting before you.
Yeah.
Yeah.
I think, see, this point is well taken because there are going to be several mineral system types there, starting with SEDEX to MVT to copper gold. You've got several and graphites also and non-metals also. I would suggest that exploration probably would involve targeting a specific deposit type. And all these deposit types are going to have their different inputs. I can't use the same parameters that I use for SEDEX for phosphorite. So you have to come up with the deposit type that you want to target, work on the mineral systems, find the proxies, find the predator maps, feature extraction and integration.
So
So instead of working on the whole package of all the 5-10 different minerals, pick up one mineralization style and work on that. We need a good area. Doesn't matter whether it's gold or copper or any specific commodity.
So we can limit to specific deposit rather than all the minerals.
See, what has been shown in the presentations was that these are all the commodities available there. So the one that you target, you can target a specific commodity.
Okay. Fine, sir. Thank you.
Somebody proving some more deposit.
That's good enough.
Certainly.
Certainly.
If you target one, so that's why you have taken that large.
Well, that's a challenge.
For any integration of data, we require a large area.
Yeah, I think a small clarification to, I think, probably both the questions. One of the things you're seeing is the vast amount of data or the big data challenge. just as there is possibility of group of companies, there is also a possibility of having people from all groups of ages, in addition to the all kinds of domains. So you actually find that interns these days, by at least the summer interns itself probably get to do this in probably a week kind of time. But then this sort of amount of data is actually nothing. So one suggestion there is to look for not only group of companies and also group domain experts, but also people of all kinds of age group.
Yes, yes.
Yeah, one small question. So, because this is a contest, and then there should be a proper evaluation metric which is should be shared, I guess, on which you're gonna do the testing and all. So yeah, just again, I think it's a repetition of the questions which have already been asked. So having one proper evaluation metric, keeping it public would clear, even in the training process, it would help.
We have given a marking system. Document in Devkumar as well as
a function, if it's possible.
See, this is
Mathematical
not, this
function.
is not an objective.
No, it's
test.
not an objective.
You have got, multiple choice type that these are the, see, these are the way we assess students, the way we assess answer sheets. So there is going to be
Huge
look at
subjective
lot
elements.
of things, and everything cannot be quantified if you cannot put it all in a matrix form.
But there is saving grace, there are 5 of us. So don't worry. There will not be much of a subjective bias. Anyone else? Okay. Fast, quick question. Karunakar.
Yeah, my name is Karunakar, sir. I'm CEO of Steiger Geoscience. We would like to participate in this. And my question is like, you have shown the geophysical data of very old BRGM, OHR, or your TOS data. But I believe I worked in Hindustan Zinc, and I have seen good resolution airborne data. So that will that be available, geotem data, that if I
Not
specify?
available with us. So whatever is not available with us, we cannot provide. So that's the problem.
So can we, means
You want to use it.
Rajasthan?
You have it.
It means we have to get it from
No,
Rajasthan.
we don't have it. So if you want to additional information, wherever you get, use it. We are not stopping you. By all means. But
Okay.
we don't have it. We are not providing it. So that's it.
Okay, sir. Thank you.
Good afternoon, sir.
Who's that?
Sir, here.
Where?
Good afternoon,
Okay,
sir,
okay.
here. So this is Suresh from GeoInfi Solutions.
From Geo?
GeoInfi Solutions. We are into remote sensing and hyperspectral and deep learning models. Sir, the basic question is that unlike software engineers, it is rare to find out a geologist.
Can you keep the mic close? We are not able to hear you.
Sir, see, unlike software engineers, it is rare to find out geologists. So if we want any subject matter expert to help us in developing the model, like from a reputed institution like NGRI or something like that, is it possible for us, or any one of you from the committee can help us when we approach to us to certain kind of
We
things?
can't be a participant.
Well-
We cannot judge ourselves. Sorry.
Okay, but my question is that can we get a subject matter expert
You keep it in a team, a subject matter. We have no problem.
from an institute like NGRI or any other thing?
We have not constrained you. There is no constraint.
Okay, is it
Not from GSI, not from the jury for sure.
not from the jury for
You,
sure?
you
not from
cannot
the
have Mora in
GSI.
your team. You cannot have. If you have him, then you're out.
Right, sir. So that's not a disqualification if we get some subject matter expert.
You can collaborate.
I can
We have
collaborate.
not constrained you.
Right, sir. Thank you so much. Thanks.
Anyone else? You will have 15 days to interact with our team, so there's no problem. Any other question you can surely ask later on, subsequently. Okay, I think. Thank you, all of you.
Any further queries from the participants who are going to likely to participate in the hackathon? Otherwise, we can conclude the session. Acha, anybody in the online would like to ask any queries regarding participation of hackathon? It's around 50, sir.
50. So maximum 5 questions, please, not more than that.
So I think there is no queries from the participants who are participating through online. So we can conclude the session, this interaction session. Thank you, jury members, for interacting with the participants and clearing their doubts. Thank you, jury members and participants who are actively participating in these interactive sessions. So with this, I request the jury members to take over the. Yes. Thank you, jury members. We are moving forward to the next episode of this hackathon technical sessions. So that is the next presentation by the T-Hub. So I request the representative from the T-Hub to present the technical session. The representative from the T-Hub. The representative from T-Hub, please come forward for your technical presentation. Anybody? T-Hub, please come forward. Sorry.
Great. Good afternoon. Good afternoon all. I represent MATH, which is a Center of Excellence for AI ML, supported by the Department of Science and Technology and an extended arm of T-Hub. So here we come planning to make Hyderabad the AI capital of India, where math is the first step that we are trying to put in across. So what is math? Math is the abbreviation of math is Machine Learning, Artificial Intelligence, and Technology Hub. So that is what math is all about. We being the Technology Hub and the Center of Excellence, we would like to first show what T-Hub has been doing for the last 8 years, which it's been got into existence. We have built about 2,000 plus, we have helped about 2,000 plus startups to go into the next step. We have had about 1.94 billion, about $2 billion in funding, gotten funded to the startups. We have about 20 plus investment firms, VCs, and other investors, individual investors coming in places. And then we have about 200 plus mentors who've been in our network. Then we have about 100 plus value partners. Value partners are there, people who help you build the startups. This starts with right from the lawyer to register your company, then to have somebody on board and then help you out with it. Then for the Google credits or any kind of cloud credits that you need, these people or that value partner desk would help you out with it. And coming to the international connections, we have about 300 plus international connections. This includes your colleges, the companies, corporates, and everybody. Then we had been doing about 110 plus customer engagements and corporate engagements for the startups here. So basically corporates coming with the problem statements, we help our startups to engage with them and then solve the issues that they have. Last but not the least, the innovation partnerships, we have about 90 odd. So what is AI ML? AI is nothing but making the system smart and then think like human. What is a machine learning thing? Machine learning is nothing but you feed in data and then it gives you the required results and then it thinks as a human predicting something that you are looking at. And then coming to the global landscape, this is what right now we are looking at the global landscape of AI and ML. These are the top 7 these are the top 7 countries which have been using or started using AI in the system as such. India is currently placed at 7, but most probably it would come in the top 3 in the next 3 years. That is the prediction as such. And then these are the top trends in AI/ML as on date in the global landscape that we have. And this is the current AI companies market size or the growth rate in the in the global AI. In India, if you see, there are about 6,200 plus startups who have been, or the corporates who have already started using AI. And Hyderabad or Telangana, we have about 500 plus startups who are there. And then out of the 500 plus, T-Hub is already associated with 110 startups which are already working. And we at Math, this is the landscape of Math today. So we have about 85 plus startups who are working in our co-working space and physically present and under one roof. This is one of the kind incubation center where you would find 80 odd startups working together on AI/ML projects, on different AI/ML projects and sector agnostic. This is the current startup stage that most of the startups are. There are about 5% startups in the ideation stage, 10% startups in the POC stage or the prototype stage. Then about MVP stage, there are about 20% and 15% are in the growth stage. This is a sector-wise, devolution of startups which are part of the Math ecosystem or presently working in or part of the programs as such. And this is the business models that most of the startups are using at this point of time and the technology accordingly. Then what does Math offer to a startup which comes in to its ecosystem or the incubation center? To start with, co-working space is what we give the basic at a very nominal price. Then market access. Market access is basically for the startups to come in and then they're looking at some kind of a funding, some kind of connections with the corporates where they can go and start getting the revenue generated. So what should AI/ML startup do, or how does the AI come into existence? So if you start with, if you want to build a model, you need data. So for which we have our data lake, where we are trying, because we are both tied up with the central and the state governments, we're trying to pull in as much data as possible and then make it available, at a nominal cost or at a free, on a freebie basis to the startups, anonymized data, which can be put in and then start building the model. So once you build the model, you need to tune it. So for which, we have our computing lab here, where we have right now tied up with the couple of data centers, E2E and PyData, where they're coming in and then helping us, the startups, with basic pricing. So this is a nominal pricing that we are putting in, apart from the with 30 to 40% discount we're giving to the startups as such. Once these are done, you need to move to the next step. That is, make your startup move from one stage to the other. That is where our accelerated programs come in. We have two kinds of accelerated programs. One a structured 4-month program, and the second is as ask whatever you want, and then we get you to the next stage as it is. Then, I have a short time, so I'm just skipping a couple of things. So the stakeholders and the mentor desk, it is a separate thing that I've just talked about. So we have a separate desk for the mentors and the stakeholders who can take care of the requirements that they are looking at. Last but not the least is the LMS platform or the learning management system, which we call the Nurturing AI Minds, where all kinds of new courses of AI are being put in, and then this is available on the system. And lastly, the AI Career Finder, specifically for the AI startups and the corporates to host their jobs like the Naukri that we have. This would be exclusively for the AI system as such. And these are the major startup concerns that most of the startups come in from, and these are the things that we are trying to address accordingly with the offerings that we are giving. So these are a couple of startups that we have with us in the system. And there are about 60 odd here present, but then there are another 15, 20 which we couldn't add in here. And these are the clientele of our startups right now in the ecosystem as such. Thank you, team, for giving me this opportunity to talk here. And thank you for being a part of it. Thanks.
Thank you, Anirudh. We have come to the conclusion session of this Mineral Exploration Hackathon technical session. So I may request Anindya Bhattacharya sir, DDG, State Unit Rajasthan GSI, to propose the customary vote of thanks.
Good afternoon, ladies and gentlemen. All good things comes to an end, and at the end of today's technical session, it's a privilege to propose a vote of thanks for a program of this magnitude. At the outset, I wish to thank Ministry of Mines for their constant support. And today we have with us our Director General, Sri Janathan Prasad sir, who is a constant motivation for a program of which brings together the academia, the industry, and also the technical persons from different fields. Now, as we all know that the mineral hackathon, the exploration hackathon, which has been organized by GSI under the aegis of Ministry of Mine, it is aimed at providing a platform in which the classical methods of exploration gets an input from the new technologies. I think this a day marks a kind of a paradigm shift in which we can definitely look forward in the future years, in which we can shift from the the classical methods to a more organized, more scientific way of looking into the things, looking deep into the art's crust. Now, first of all, as we all know that the second session that we had, the innovative mineral hunt techniques, it was initiated by the presentation by Sri Dipkumar Bhattacharya, who is the DDG and HOD of RSS Bangalore. And in this presentation, he has wonderfully had given the clue of the rules and regulations which is being to be followed in this hackathon. Thank you, sir, for your presentation. It was followed by a very technical, detailed presentation by Sri LMS Maura from he's DDG and RMH Mission 2 of Western Region, Jaipur. And I think that was a very extensive kind of presentation, sir. And I think this definitely have imbibed the interest of all the participants. And Mr. Dipkumar Bhattacharya is one of the main architects in this hackathon process. And thank you, sir, for your regular participation and regular motivation of the team. And you definitely lead a team of very motivated officers that we have from Bangalore, from Jaipur, and also from central headquarters. And Mr. Elmas Maura will be leading the technical team, again, which contains a lot of very talented people from Western region and also from RSS Bangalore and also from CHQ Kolkata. I also thank Mr. Diptangshu Sengupta, Senior Geologist, GHI CHQ, and for his presentation on highlighting the registration processes. Thank you, Diptangshu. Next, I think it's my time to thank the panel of judges. I think we have an August gathering of panel of judges in which it is being chaired by Sri Joyesh Bakchi, ADG and PSS of GSI Central Headquarters. And we have an expert from the academia. We have experts in the field of geoinformatics, in the field of geology, and IT experts in the form of Dr. Alok Porwal, Professor IIT Mumbai, Dr. P.V. Arun, IIT Tirupati, Dr. Anand Singh, IIT Mumbai, who have joined online today, Dr. Surendra Somla, IIT Hyderabad. And I think this is a kind of a team which has both experience and youth in that. So I will definitely put on a message to the participants that you have a wonderful team of reviewers and the panel of judges. So buckle up and for the next 2 months. Next, I'd like to thank the presentation by Mr. Anirudh from T-Hub, who have made a very interesting presentation in making Hyderabad as a kind of IT and a leading city in the AI/ML platforms. And I think I should also thank Dr. Sundarlingam, Senior Geologist from GSI TI, who has been successfully anchoring the program. But finally, I think it will be, I should definitely thank every participant who have joined And I think we have a different area of participation here. We have people from the state governments, we had people from different PSUs, we have participants from startups, and people who have a background in geology, background from IITs. So it's really a very interesting and a wonderful way of concluding a program. I think, first of all, I thank the people who have joined us on physically here and also to all the participants who have joined online. And thank you so much for today's participation. I wish you a very happy stay at Hyderabad and a safe journey home going back. Thank you, sir. Thank you.
Thank you one and all for joining with us. With this, we are concluding this mineral exploration hackathon. Thank you one and all.